Hello, everybody. It's 2:50 a.m. Central Time on the 6th of March, 2023. It's Monday here in the United States. Hope you're doing well. We are here on the Earthquake 3D live stream, recording live at least, live on Twitch if you're not aware, if you're watching back on YouTube later. But let's go ahead and just go turn on a display capture so you can see what I see ever so slightly better. And we're going to talk about the earthquakes which have struck over the past few days, as well as what's going on over here in Turkey, and my 7-day warning for Turkey expiring without the expected earthquake. We'll talk about that. First things first, we have to talk about the 7.0 earthquake, 6.9. that you see here north of New Zealand, south of Fiji. Now, we have to go back about 8 days, 7 or 8 days, where we talked about this location down here from the two X's at Point Nemo. Following those two fracture zones, look where they go. They go right back up to the Kermadec, and we talked about Kermadec to Point Nemo. Why did we talk about Kermadec to Point Nemo that many days ago? Let's look through the planet. And what you'll see on the opposite side of the planet are a bunch of other rings. Those other rings right there, that's Turkey. That's the antipode, the opposite side of the planet. And we normally watch for opposite side of the planet movement within a few days to a week of a big earthquake. That's according to the professionals. You start to watch for antipode earthquakes, whether it's the opposite side of the planet or the sphere or whatever shape you want to put it. We're on the one side and the other. Turkey on one side, opposite side of the planet, down here from Kermadec out towards Point Nemo. So why were we going to look for a 7 here? Because of the 7 on the opposite side of the planet. According to all the antipode research, professionals studied 5,000 or more different 6.0 and greater earthquakes, and they found within about a week or less, there's usually a fair amount of movement on the opposite side of the planet from where a big earthquake happens that's similar in size, 6.0 and greater. Well, we're talking 7s now. And then we have to talk about the deep earthquake that likely set this into motion over here on this side of the planet. So a few days back, there was a deep 6.5 raised high off the globe here. We'll get it on the screen there. There it is, marked in dark pink. If you're new here, the earthquakes that are deep, the deeper they are into the planet, the higher they are off the globe, so we can see them easily. Anyway, we had a deep earthquake here below, technically Solomon Islands, but that's eastern Papua New Guinea. I'm going to turn on a USGS plate boundary map. This should help us a little bit in just understanding what's moving. Down below right here, hopefully you can see this where my mouse is, here on the screen, Papua New Guinea. I'll back it out now, and you'll see the plate boundary between India, Australia, the Indo-Australian plate, and the Pacific. So a deep earthquake happened here several days ago. Let's see, when did that happen? On the 1st, so 5 days ago. Then, following that up, this earthquake struck over to the east. Now, I have to remind everybody, when this deep earthquake struck, I'll turn on the shell feature here, and you'll see it makes like a dome or a bubble spreading out and away from where the deep earthquake is. And make note that it goes over to the east, all the way over to here, to the edge of the dome for this big, deep earthquake. Now, why does the dome matter? I want you to think of the dome like a bubble coming in on the underside of this. On the underside of the Indo-Australian plate. Spread up, out, and away over to the east. It will also spread over to the west and to the north. 7 to 10 days is what we watch. And on day 1 into day 2, this happened. This is a 6.5 to 6.7. So that struck first. Then our new 7 struck on the antipode of Turkey over here. So really, it's 2 significant sized quakes striking over to the east. Now, a new 6, or a 5.9, 5.8, struck down here on the south side of the plate boundary. This is all in the past 2 days. Let's show you again what moved. First, down below here at Papua New Guinea on the north side, of the Indo-Australian plate. Then, next to it, 6.5 to 6.7. Then, next to it, 6.9 to 7.0. Then down south, 6.0, well, downgraded to 5.8. We're moving all the way around the outside edge of the Indo-Australian plate. Now we need to talk about what's going on the other side of the Indo-Australian plate, which is this. A span of fours, upper fours, 4.9 to 5, going out in the past 2 to 3 days. You can see it. We'll get our fours on here, and you should be able to see just a mess of quakes in the last 48 hours. It's a lot. Last 3 days really fills it in. And you see a stepping stone path of earthquakes about the same size. 5.0, 5.1, 4.9, going across and around the bend of the plate boundary and up and around the bend of the plate boundary. Around what? This. See it? The spacing of the quakes. I'm going to show you something else now. Video that I have queued up now. So with the deep earthquakes, I think what's going on down below the plate is something like this in the magma. A concentric standing wave spreading out across hundreds if not thousands of miles, made of very low frequency electrically induced down in the plate. It then hammers in on the underside of the plate. The full force of the full wave over hundreds if not thousands of miles focuses in on a singularity and makes a spike and hammers in with the deep earthquake. Like these here hammering in on the underside of the plate where the deep earthquakes are raised high off the globe, or where the big deep 6.5 happened, raised high off the globe there. So imagine that, this one, this big deep quake, like this. Hammering in, focusing in, and then it goes up into the solid plate. When that happens, a wave then is generated and spreads out like a bass drum hitting and reverberating around the outside edge of the drum. That wave, when coming up through the plate, forms into what's called a standing wave. Multiple beats of the drum in a closed container of a chamber containing the wave, reflecting back into itself. When it reflects back into itself, look what happens. Notice, the peak of each wave starts to rise. The magnitude increases, the amplitude, the power, as it pumps back into itself. It doesn't get disorganized in the chamber at all. Now, I'm going to park my mouse over the peak of one of these waves, and you'll see then the middle of the next opening, the bottom of the wave, the trough, fills in the peak. I don't even have to move my mouse. It just stays there. Peak, middle, peak, middle, peak, middle, back into itself as the intensity increases. As it gets pumped up with more energy, the wave starts to rise. This is a standing wave, but really the rising wave is just the power. Think of it like that, the magnitude. Now let's get back to the earthquakes. That standing wave that I just showed you in the tank, equally distributed through the perfect rectangular tank, is going through this, the uneven wave tank of the plate boundaries containing the wave. So one more time, guys, you got to understand this. Again, this is for all the new people. First, energy comes hammering in on the underside of the plate with a deep earthquake. Then it forms a standing wave and spreads out. As the standing wave spreads, it drops off new earthquakes along the way, all about the same size. So, for instance, 5.0, 5.0, 5.0, 5.0 gets down to the end of the tank in the laboratory here, reflects back into itself. All of a sudden, we've got 5.2, 5.2, 5.2, 5.2. And it strikes at the middle points between the waves when it's going back. Watch. Reflects back into itself, and then the wave comes back up. Boom. Boom. Okay, so as it reflects back into itself, the wave increases, the intensity increases, the magnitudes go up, the amplitude increases. Now, as we get more new deep earthquakes, it's like pushing more into the tank. So we're not just dealing with one deep earthquake. We're dealing with several that are pumping into the tank. And the tank starts here, and then it connects to the north, to the west, and all the way across over to the opposite side of the Pacific. And that's what's going on now. The spread is going out, up into Japan, reaching as far north as Hokkaido. Go back 2 days, Hokkaido got struck right there. And let's look at all the 5s. You should be able to see this. Well, let me take it like a world away. You should be able to see it. That we're going up to the north and over to the west. Or up to the north and over to the west. Well, what's up to the north and over to the west? This. Up to the north, following the plate boundary to the north, and over to the west, making a curve and curl back up into Myanmar. And what struck in the past 2 days? A line of earthquakes making that bend. Right around the outside edge, 2.5 days ago. Now, the new earthquakes marked in a light pink color have struck in a row across all of the Mideast, going from Afghanistan back up into Siberia, Russia, north of Mongolia. And let's just go over here and take a look and see what moved. USGS doesn't have anything on here, right? Plate boundary map goes through India, the north side of the Indo-Australian plate. You don't see anything across here. Let's go back and take a look. What's really there? The plate boundary makes a bend through Afghanistan, goes back down into Iran. Now, USGS has it marked here, and the mountains themselves show us, let me show you. Go over here to the Mideast, over here on Google Earth, and you can see the bends in the shapes of the mountains themselves. Let me turn off all of our borders and labels. And we go down and around this way, following the plate boundary to the south. But you'll notice it looks like a flowing river. It's going around the center part of the craton, the center part of the plate. It's going around to the north. The mountains, I mean. Well, guess what else goes around to the north? The earthquakes. So we should see a new break in Iran. Iran-Afghanistan border region, South Turkmenistan, east of the Caspian Sea, and this now gets me into this big open area and what it means. Let's go back 3 days, 4 days, 5 days. We have to go back 5 days to get anything reported out of this area, which is Iran. Let me show you how this is connected. I just got done talking about the Indo-Australian plate, and I just showed you Iran lacking earthquake activity, majorly lacking. While we're moving big time up here, need I remind everybody, Tajikistan got a 6.8 to 6.9, let's just call it a 7. Upper 6 to low 7, struck at Tajikistan last week, and the 2 7s, plus all the other activity over here at Turkey. So wait a second, Tajikistan, 7, Turkey's 7. In between the two, pretty much radio silence when it comes to seismic activity. Low, 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 low. But look what connects between them. The Indo-Australian plate boundary meets over to Saudi Arabia and connects all the way into Asia. That plate boundary there has to be under serious stress. We already broke on one side, Tajikistan 6.8 or 7, and 2 7s on this side. Now in Turkey, 8 days ago, I issued a 7-day watch. My 7-day watch was for up to a 7.0. What hit? A 5.6. Took down buildings, struck 90 miles away from the original earthquake epicenter, a different earthquake, like 16 days after the original big earthquakes. But that is way low. Way low. Too low. I consider that a full earthquake forecast miss, even though the earthquake struck pretty much in the area where we were looking, the 5.6, just east of the previous large earthquake, but it is a magnitude, maybe a magnitude and a half under what I was looking for. If it was a 6.6 or a 6.7, that would have been the earthquake we were looking for. But I'm a full magnitude under, and whenever I miss something by over a magnitude, even if it strikes in the area where it hits, unless it's significant or something, I consider it a miss. So did an earthquake hit? Yes, but it's not an aftershock. The earthquake which struck is in an entirely different location, far away, like 100 miles away or more, or about 100 miles away from the previous 7 at Gaziantep. So different quake. The 5.6 took down buildings that were damaged from the 7, and it did cause loss of life and injuries. But again, it's a magnitude under. a magnitude and a half almost, because I was looking for upper 6 to low 7 to come into Turkey east of the previous 7s. That's what we were looking for. And the 5.6 struck on day 5 of the 7-day watch. So what happened? Well, in between the time where I issued the warning for a 7 for Turkey, Tajikistan broke, and I did not change the forecast for Turkey. So Turkey goes back 2 weeks on what we were looking for and the breaks to keep happening and so forth. Then Tajikistan broke. Now look at the earthquakes over the last, let's just say, 2 days. And this gets back to Iran. So what happened? First, Turkey broke. An incoming wave like this came into Turkey. This goes back 3 weeks now, almost a month. Incoming wave from the previous deep earthquake event came flowing in along this, the plate boundary. Came in through Iran. You know how I know it came in through Iran? Before Turkey broke, a 5.9 to 6.0 devastating earthquake, may have even been bigger, struck in Iran. Iran was begging for international help. Do you guys remember this? It was about a month and a half ago. So, what happened? An incoming wave from deep earthquakes came across the West Pacific. We saw an increase in seismic activity big time over in the West Pacific first. Then the flow went out over to Iran, struck with a 5.9 to 6, devastated Iran. Then the wave got to Turkey, and it reflected back into itself at that point. And I'll show you where it reflected back into itself. So this wave was traveling from over here, and it was going across and over into Turkey, where it got to this point here and got reflected back into itself and built into the standing wave, where it broke with the 7.0 earthquake right here at Gaziantep. See where it says Gaziantep on the screen? So at Gaziantep, the break took breaks, plural, took place, and a 200-mile-long surface fissure fracture formed in the general direction that this thing's pointing, across interior into Turkey, back up towards the plate boundary, coming out of Iran. So let's recap. A big wave generated by multiple deep earthquakes came across, dropped off as 6 in Iran, came into Turkey, reflected in itself, into itself, right in this stretch here where there's no plate boundary mark, and broke, literally broke, up to the surface, causing a surface fissure fracture 200 miles long. You can't call it aftershocks when it's spread out across 200 miles, multiple large earthquakes, plus multiple 5s and near 6s. So a new break took place going between the African plate across the north side of the Saudi Arabian plate, or the Arabian plate, whatever you want to call it. That's a big deal. Then the wave reflected further. A new push came in. We watched a big arrow of earthquakes pointing into Turkey, prompting me to issue the new warning for 7.0 level activity to come into Turkey. And let me make sure you can hear me. Okay. So when I issued that warning for the 7, we had a big arrow of earthquakes pointing in somewhat like what we see now, a generalized arrow shape of quakes pointing into Turkey. And then the 5.6 struck, knocking down buildings. It could have been a bigger earthquake. It could have been a 6, but even then, that would still be about a magnitude under what I was looking for. But then the wave reflected back into itself, back over towards Tajikistan. I think that's where I got it wrong. So, I full miss for me. And I'm not going to be doing any new forecast for Turkey until I fully figure out, and we'll know in the next few days. It won't take months or years to figure this out. We'll know where the next break happens, and that'll let me know where this wave currently is. I mean, I already know where it currently is. It is somewhere between Turkey and back over in the West Pacific, because out in front of Turkey, and when I say in front of, look which way our arrows point. Or let's just say downstream from Turkey, there's been very minimal earthquake activity except for Romania. And one earthquake 2 days after Turkey, which was right here on the Adriatic. Now it's been 2.5 weeks of Eastern Europe remaining pretty quiet, while all the activity has been focused here and back over to the east. And that to me says this wave has not spread beyond right here. See where Greece, Albania, Romania? The wave reflecting back into itself at this point has not gone beyond here. We have not seen a new break, and we have not seen any flow go out. Instead, it went back here, back over to Tajikistan. The wave is reflecting, which means we have to watch the halfway point between Turkey and Tajikistan. And what's the halfway point between the two sets of quakes? Between the quakes here in Turkey and the quakes here at Afghanistan, going down into Pakistan. You see it. Halfway point is the big open area with no earthquakes in it. Now, if this gets filled in even with 4s or 5s, that'll complete this. If this middle point gets filled in, then we'll know the flow is coming back over to Turkey. Right now, it's somewhere between Tajikistan and Turkey, and it's getting pumped in with a bunch of new energy. So I would warn the people in Iran, east of Turkey, for a new break to take place. I'm not issuing any new warnings for Turkey. My warning has expired. You understand the reasoning now that went into it? It obviously did not take place. A 5.6 as opposed to a 6.6 is a big deal, in my opinion, to get wrong. And there it is. If you live in Turkey, here's what I want you to watch for. Iran to break. Watch for a break in Iran. And if that takes place, that lets you know where the wave is. Watch for a break over to the west as well. Not that we want to see these people get hit. We do not want to see Central Europe get hit with any significant sized earthquakes. However, if you see 5s go out across the plate, out across all the way, then we'll know Turkey's finally releasing. I'm thinking of this like a dam. Or you could think of Turkey down here at the end of the tank closest to us, blocking it right now, the wave, sending the wave back into itself to build up more. And I think that's why we got our surface break, our crack in the ground, our surface fissure fracture, if you will, that goes all the way across in pockets back over to the east, to the Iran border. Something else I'd like to point out, we're now seeing small earthquakes get reported in the Black Sea, North Turkey, Crimea, which is somewhat rare. We don't normally see activity up here in the Black Sea or up in Crimea. We got a 4 up in Crimea a few days ago, now 3s. I proposed this scenario a few days ago. Before any of these earthquakes were here, I talked about the potential for, in the past, once we saw earthquake activity, seismic, the wave that I've been talking about, instead of going through the plate boundary, through the red line, instead of going through Turkey, it went up through the Black Sea, up through Russia, and out to the north, across Finland and up to the North Pole. And it dropped off an earthquake in Russia right next to Moscow along the way. Instead of going over to the west, it went around the wave. It was a big push. We got a 6 at Moscow and then a 6 out at the Mid-Atlantic Ridge, where the red line is out at the Mid-Atlantic Ridge by Iceland. That was many years ago. I've only seen it happen once. And it was when Turkey was previously breaking and broken and blocked with another large earthquake that had happened several years ago. I want to say it was like 2012 or something. It literally was like a decade ago when it went around up through Russia. So normally the flow follows this like a waveguide. So these red lines, the plate boundaries, are containing this very low frequency wave coming up from down below. You've got to remember this spacing thing on the wave, because the spacing on the wave matters. We're going to talk about this again in a second up in Alaska. The spacing on this wave in the tank, same sized earthquakes, whether it's 1s, 2s, 3s, or 4s, the standing wave can be low power or high power. 1s, 2s, 3s, 4s, 5s, 6s, 7s, and 8s. We've seen back and forth. Now, I mentioned Alaska. Remember the wave I just showed you in the tank. Because look, 4.4, then going down to 3s and 2s, up into the plate. Perfect spacing. We're going from a wave out in the ocean along the plate boundary. Well, not in the ocean. A wave out on the plate boundary, which just so happens to be in the ocean. This is down on the plate. And then once it gets into land, it takes a step down, power-wise. The plate is absorbing some of this wave's energy. Not much to go down from 4s to 2s across that distance, but the wave spacing is perfect. The equidistant spacing of the quakes. And that matters because the equidistant spacing on the quakes matches the equidistant spacing of a standing wave. This standing wave is very low frequency in the tank here. And if we get over here and we're looking across the distance of, let's see, 100, 200, 300, 400, 500 miles or so between each wave peak, it's dropping off an earthquake along the way as the wave is traveling. Now, it's not perfectly domino affecting. It's a wave is going through this area and it's dropping off the earthquakes, almost like a game of leapfrog, because that's really what's happening in the tank. Take a look. The one wave goes over and comes up below the next one. Then it comes back and comes up in the peak of the middle of the open spot. Leapfrog, back and forth. So think of these like quakes. Then as it gets pumped up with more energy, the magnitudes go up. Let's go up and take a look up into Alaska. So what I just showed you on the USGS page can be seen here easily with the rings. It looks like a stepping stone path laid out through a curved garden. So, got a curved garden. My wife wants me to lay the path, and she wants the stones evenly spaced or somewhat evenly spaced. That's about as good as a job as I'd be able to do anyways. Look at it. It's not that I'm awesome. It's that Mother Nature's nailing it almost perfect. I can't lay a perfect path, but somehow this is happening. Now look at the magnitudes. We got 4.0s on either end, and in the middle we have 4.2 and a 4.4. Bigger in the middle, right? Now I want you to think of each end with that wave going down and back into itself. And it's still being fed some energy from over here on the west side. Or think of it like it's being pumped in at this end, and now these waves in this tank are going to increase in magnitude or amplitude. Amplitude, magnitude. So we would go from 4s to 5s. But then when this wave intersects something like, let's say, the North American Craton. Hopefully you can see that. When this wave intersects the North American Craton, it takes a slight step down from 4s to 3s, and then from 3s to 2s, and from 2s to 1s. But it's not that much loss of energy either. It goes across the whole plate to do that. We're talking about some kind of very powerful, very low frequency wave that's spreading out across the planet. We know where it's coming from. Again, the big bass drum beating up from down below on the underside of the plate, reverberating up, passing up through the cracks in between the plates. You got to think of these red lines. If you're new here, guys, I want you to think of every one of these red lines as a crack that starts at the surface, whether it's down in the ocean or on land, it doesn't matter. Starting at the surface and goes all the way down through the plates, down to the underside. So it's where two plates meet up. It's a seam, if you will. Could just be a hair apart, or could be feet or bigger apart in some spots. Gaps, if you will. Anyway, crack that starts at the surface goes all the way down through the plates to the underside. Then we come in and we lift on the underside. Or we do a big bass drum on the underside. And we've already got the cracks between the plates where the bass drum's hammering in. What do you think is going to happen with that vibrating wave? Which way do you think it's going to go first? Of course, it's going to go across the whole mass of the plate, but the mass of the plate's going to absorb it for the most part, right? According to elasticity and so forth. But if you give that wave a way out or a way up, guess what it's going to do? It's going to follow it out and up. And you can go ahead and lift on the underside of a big slab of stone that's got cracks in it to find out and do the experiment on a small scale, on a microcosm scale, or on a vast scale. The vast scale is going to require a vast amount of energy, and that's what we're dealing with these huge, big, deep earthquakes, equivalent towards, a 7.0 earthquake, equivalent to several, how many nuclear weapons? Anyway, a big impact on the underside of the plate spreads out away, and it drops off this wave across the way. We get into North America, and that's a big deal. Okay, North American Craton. Let's show you that graphic again. The North American Craton absorbs the energy. Well, not just the North American Craton. Every craton absorbs the energy. I just got done talking about it in Europe, going out and across around Europe, around Iran, and so forth. But we get over here to the United States, and you can see it goes into the plate and goes across it. Oh, I've got people messaging me telling me that they want to know about what to look for in New Zealand. Okay. Sorry. Okay, down in New Zealand, guys, first of all, 7.0 right on your doorstep, right? Let's go show you what's going on. Sorry, guys, I hate to have to do that, jump back over to the United States, but this is a big deal for the people in New Zealand. So up here, Kermadec Island, 7.0 quake. A bunch of deep earthquakes up here on the north side of Fiji. We had a 4.8 down here on the south side of New Zealand, and USGS chose to ignore that earthquake, guys. The USGS just literally ignoring it, but even with them ignoring it, you can still see the greater quakes on either side. Now, what would you say the halfway point, if we just drew a straight line from this earthquake all the way down here on the south side of the Indo-Australian plate, up here to where this current quake is marked, up here at Fiji, it would take us on the western side of New Zealand, wouldn't it? But if we went down and around the bends of the plate, and then back up and across the Cook Strait, and then off the east side of New Zealand, then the halfway point would put us somewhere more like right in here. Wouldn't you say? Maybe a little further south? Right here? Where is that? That's northwest of Christchurch? Between Kaikoura and Christchurch, halfway point. So, new 4.8 struck last night or yesterday, right here, just south of that halfway point. So it matters if a quake gets reported or not by the USGS, because it would be on this screen or it would be on this screen. And then what you would see is a 6.9 up here to your north, then a 5 on your north side, just north of New Zealand itself, a 4.2 in the Cook Strait, down below the catcher's mitt position, right here, and this is a deep earthquake down at 337 kilometers deep. Something's going on down below the catcher's mitt of the Bay of Plenty. We call it the catcher's mitt because it looks like one. And it catches the energy as it's coming up from down in the basement, coming up to the first floor. Down in the basement's where these deep earthquakes are. The ones up here to your north that are raised high off the globe. You got your 7 on the north side. You got a 5 on the north side. Then a deep quake on the north side. Skip over right here in the center, you get a 4.8. Let's call that a 5. And down here to the south, you get a 5.8 to 6. So in other words, 6 on the south, 6 on the north, a 5 in the middle. Now what are we going to look for? We have to divide it in half. A new earthquake's going to strike on the North Island next to Wellington, maybe central part of the North Island, and a new earthquake is going to strike La Esperance Rock, I can't even pronounce it right, down here south of New Zealand. If it strikes out in the ocean, I don't think anybody will care. Strikes on land, everybody will notice. Both earthquakes should be in that upper 5 level, so, I mean, North Island and New Zealand, you should see something like a 5.8 to 5.9, just like the one down to the south. Same with down here in the ocean, down to the south of L'Esperance Rock. So I would expect the North Island of New Zealand to get the significant quake, since the middle's already been filled in by a 4.8 that our agency is choosing to ignore. Okay? If you saw that 4.8, it would be a perfect, that wave that I'm talking about, you would see it. You'd see earthquakes on the north side, earthquakes on the south side, and an earthquake in the middle. And then that would just be like a wave on the north side, wave on the south side, then it reflects back into itself, and the new wave, the combined total of both, comes up in the middle with something bigger. This standing wave thing's huge. It really is, because it means there's something traveling across the plates that's dropping off the earthquakes. It's the force that causes earthquakes. That's what I found. I'm not bragging. I mean, I just have to tell you, that's what's been found. There's something spreading across the waves, dropping off quakes. What could it be? Some kind of very low frequency of some kind, or ultra low frequency, or extremely low frequency. Has to be electrical in nature, not just vibratory. But it's also physical in nature. It's going around things as opposed to directly through them. Like the Craton, for instance. Take a look at the last 7 days worth of earthquakes. I'm going to turn off the magnitudes just so you can see the actual quakes themselves. You should be able to see that this is a perfect match going from the west coast. Here, let me turn down the rings there a little bit. There we go. There. So, western edge of the craton, the accretionary belt over along the west coast, going up into Washington State. Then it goes out and over across. Now, make note of where our arrows are. So, we have an arrow coming from Washington, going down into Idaho and pointing over further down to the east, southeast, down to Texas. Now, look at the earthquakes. It's a perfect match. Last 7 days. Comes out of Washington, goes across our red arrow, over to Idaho, then over to Yellowstone, then down the edge of the craton to Texas, following through Colorado, over into Oklahoma, over to the New Madrid, and up the East Coast. This is the last 7 days worth of earthquakes. Every week, it does this very same thing. We see a push come in from the west coast of the wave that I'm talking about. Then it spreads out across the craton, dropping off the same-sized earthquakes all the way along the way. And when I say the same-sized earthquakes, we've seen literally the same-sized earthquake strike from the west coast going over to the east coast in the matter of a few days' time. Let me give you an example. 6.0 level earthquake struck out here in the ocean, up here off the coast of Vancouver Island in Washington, followed 2 days later by a 5.9 to 6.0 earthquake down here at the fracking operations in southern Colorado at Trinidad. This was in 2011. So first a 6 up off the coast, then a 5.9 gets reported here. They downgraded it to 5.4. Whatever. Knocked chimneys down, took facades off houses. Biggest earthquake in state recorded history. Then, 12 hours later, another 5.9 struck over here in Virginia on the East Coast, caused damage all the way up the East Coast, damaged the Washington Monument. This was in 2011. That was a 6, basically, but they brought it in at 5.9. So let's recap. First a 6 struck up here. 2 days later, then a 5.9 strikes here on the edge of the craton in Colorado. Get back that craton graphic again. Then it struck over in Virginia on the East Coast, 12 hours after Colorado. That's not chance. All sides of the craton moved within a couple days of each other with the same sized earthquakes. But it's not that a 6 up here off the coast caused a 5.9 in Colorado, which then caused a 5.9 in Virginia. It's not a game of dominoes. It's a standing wave was going from all the way up here, down and across, and back up across over to the East Coast. And it dropped off 3 of the same-sized earthquakes along the way. Where did that wave come from? That wave can be traced back to its origin point, where we're hammering in on the underside of the plate. I keep having to repeat myself because these are my biggest discoveries that were disputed so hard for so many years, and now it's so obvious that this is just what's happening. So, standing wave is spreading across the plate, and it's dictated by the size of the incoming waves that are put into it, into the tank, coming from the other side of the planet. United States, let's go look up the quakes. So there's a reason the earthquakes are striking in the spots along the craton. I mean, if you have a natural point where the stick point, if you will, for this wave, I'll show you an example of the natural stick point. Here's one right here in the Mideast, going back and across right in here where the earthquake struck. You see how it's curved and bent like that? Let me show you another example over here in the United States. See how, remember how it was just bent over in Pakistan and Afghanistan? We're going to get down in here and we're going to see the same structures in the United States on our folds and bends in our plate. They told us these were from glaciers. What a scam. What about the ones over in the Mideast? Oh, those are from glaciers too, Dutch. Sure, dude. Whatever you say, Mr. Belvedere, these folds and bends in the plate predate the glaciers. The glaciers just came down to these spots, apparently. You know how I know that? The old ocean front that used to be on here. Back from the time of the dinosaurs? The old ocean front, Cambrian? Yeah, not made by glaciers, guys. These are 200 million years old. Can't be made by glaciers. Okay, so we ruled out glaciers. Now we're going to talk about folds in the bends of the craton because that's the way the earthquakes are going. Down and around and over and across. Following it like it's a waveguide. But there's a reason that we're getting earthquakes at the folds. The wave is getting reflected back into itself. Look how steep of a bend the New Madrid seismic zone is. It's a U-shaped bend through the south, and the New Madrid makes an N-shaped bend to the north, and another U-shaped bend through the Wabash Valley seismic zone through Ohio. But the town of New Madrid is right down here. Right, hold on. Right here. So, New Madrid seismic zone. The N, lowercase cursive N-shaped bend in the plate is a very steep curve in the bend of the plate where earthquakes break at the steep start of the curve of the bend. Want to see another spot on the planet where that happens? Over here in Europe, on the edge of the European craton. Looks just like the North American craton, but it's just turned sideways. Turn it this way and all of a sudden it looks just like it. But anyway, over here on the east side of the bend of the craton here in Romania, and on the west side. The west side is where we just got our big break this last week in Romania. Want to see another spot where it breaks? Over here at Myanmar, where we make a hard bend to the west. See how it makes a hard fold and bend to the west? Right up here, we're coming out of Myanmar, going up and over into Nepal. What's there? This. The plate boundary again. See where it makes the hard bend to the west? The earthquakes go up, and at the pinnacle bend of the bend, where the wave has to go around that steep curve, breaking takes place, folding, impact. So in the United States, at the bends of the fold of the plate, down in Texas, up in Oklahoma, and over at the New Madrid. But unfortunately, in Texas and Oklahoma, and Kansas, every one of these spots, from where this earthquake I'm marking in blue, to the south, through Oklahoma, down to Texas, these are all next to drill points. Humans have come in and drilled, and we've drilled millions of times across the edge of the North American craton down in Texas. So that craton, one more time, matters. Down in Texas, this is what we're zooming in on. Looks like regular land out in Texas, doesn't it? No. Huge oil pumping operation just on the edge of it right here. Here are, I think these are condensing stations or compressor stations where they take the gas from all the different gas and oil from the wells that are here and then put them into pipelines. And every one of these little pads is a different oil well. And this is actually nothing. Here on the edge of the craton is where we go down into hundreds of thousands and millions of wells. And I say millions, I mean it. This is just one little spot, one little area here in Texas. Whole Texas counties are done this way. Those are not houses. Every one of these is an oil well. I'll just randomly zoom in on one. Yes, they lay the pipelines out at the surface, so if they break, they're easy to replace and they can see it easily. But check it out. Look how many there are. This is just one county. Here's what a town looks like. But the wells go through town. So you zoom in on the town and just literally through the town itself, like behind somebody's yard. Look at that. So that's what a town looks like. And then around the town are all the wells. And when you start drilling like this, on the edge of the North American craton, it's a big deal. The craton edge already is transferring that very low frequency wave across it. It would normally get stuck somewhere else through here at the bend of the plate, but I think because of the drill points, it's lending itself to break there. Guess where the other fold in the bend of the plate goes? Well, I won't make you guess. I will show you. I'm from the show me state of Missouri up here. look at the Craton Edge, now that you know what the Craton is. Comes down through Colorado. This is Colorado right here. We go down and make a U-shaped bend through Texas. Looks like a river valley there, but that's actually a bulge. This is 1,000 feet higher than the valleys down below. So go around up through Dallas, and then once you get to Oklahoma, two things happen. The plate bends hard to the east through Arkansas, and then it looks like an old fracture point goes up into Kansas, up through here. Now you've got this giant thing right here, the 5-sided thing here. Anyway, this comes up and goes up to the north and stops right about there. And then the fold and the bend of the Craton goes over to the east to the New Madrid. This is the Mississippi River Valley from erosion, but you can still see the foothills make that N-shaped bend and then a U-shaped bend into the Wabash Valley seismic zone. And the seismic wave goes down through Texas, back up into Kansas and Oklahoma. Hard bend to the east, whatever energy gets over here gets caught up on the New Madrid, and then if the push is great enough, carries on and goes around and up the East Coast. And I think this is why we used to get huge earthquakes breaking out on the New Madrid seismic zone. The wave would come in, naturally speaking, get caught up in the fold of the bend of the Craton there, break there, take a long time to happen, but it would happen. Now we can see the wave coming across at all the different drill points. So Oklahoma, Kansas, I shouldn't need to take the time to look up those quakes for you. You guys can go look them up yourself if you want to go look them up in Oklahoma and Kansas. New Madrid seismic zone, there are no drill points there. That is solely a spot where the wave is reaching to that's already a previous break point from Mother Nature. Otherwise, I don't think we'd be seeing very many earthquakes in Kansas and Oklahoma. Let's go over to the West Coast, take a look. Go see what's going on over here along the coast. Guys, are you ready? Hold on, what time is it? 3:37 a.m. Central Time? Let me go sip my coffee. Oh, dude. Do it live! Not editing this out. Yes, I am drinking coffee at 3:37 in the morning. Let's go up into Washington, and go take a look and see what's there. How many different ways can you say it? Depends on where you're from. Okay, now let's go zoom in and see what is this place? What is that? Looks like some kind of mountain that's missing its center. Never seen one of those before. What is this? Looks like a volcano to me. It's called Mount St. Helens. In case you don't know about Mount St. Helens, it erupted in 1980. It erupted again in the early to sometime in the 2000s, 2008 or something. But that was just a small ash column that was erupted there. In this case, we're seeing small earthquakes right below the center of the dome of St. Helens, the rising dome. This dome has been rising since the blast. Eventually, one of two things will happen. This dome will continue to rise, and it will fill or somewhat replace the original peak that was here. Or two, it will blow before it gets there. But right now, it's not going to blow at all. Don't worry. Knock on wood. We would see thousands and thousands of small earthquakes to accompany this. This is just the wave passing through. It's low, zeros and ones, not that big. Let's go up to the north and see where the wave is passing through to the north. If it's passing through at Mount St. Helens, I wonder what it's doing at other spots up to the north. Look where it went. The wave went down below the center of the crater of Mount Rainier. And yes, that is a crack across the glacier in the center of the crater. Right through the center. Anyway, you can see it. There's Rainier. Now that's Mount St. Helens and Mount Rainier. Up to the east by northeast we go. We're going to go up just into a place called Washington. No towns, I guess they have. It's really rural up there, I guess. So rural they don't have any nearby towns. Oh, wait, there's Leavenworth right next to it. Oh, wait, there's Orondo. They could give us the name of a nearby area like Waterville or Entiat, Washington. Entiat? Lake Entiat? Now, I do recall there being something along here. Oh, there is. Hydroelectric power generation is taking place here. Now, remember what I said about very low frequency and that wave that's been passing through the plates. Very low frequency, hammering in from the underside of the plate, but it's partially electrical in nature. Or fully electrical in nature. But very low frequency, just like electricity in the lines that we use to power things in our house, that's also very low frequency at about 60 hertz. But just think of hertz like beats per second or something in music. But that's kind of what we're dealing with here. We're dealing with an incoming very low frequency, Mother Nature. And then humans are on the surface generating their own very low frequency. And it goes out along what are called transmission lines. They transmit the power through the lines. The power is radio waves. They're transmitting radio waves through the wire. That's what the electrical current is. Alternating current and direct current, AC/DC. Alternating current is radio waves. Okay, anyway. Here's the earthquake, and the earthquake is right next to the set of power lines. The power lines are somewhat hard to see, but they go right through the mountains right here. Many, many sets of them. Now, we've been documenting this all over the world. Power stations getting hit and the transmission lines coming out from them. Whether it's hydroelectric dams, solar power, nuclear power, coal fire power, natural gas power, wind farms, if they're generating a lot of electricity and it's going out via transmission lines, we tend to see earthquakes next to the transmission lines and the facilities generating the power. But those earthquakes, I believe, I can't prove this, but I think, are induced by the seismic wave that's already in the ground. It's like a circuit board almost, that the green circuit board is carrying the power through the layers of the circuit board, and then we are on the surface putting a wire on there like it's a circuit. What do you think Mother Nature's wave is going to do when it gets to that point? I would think it would go to that point and come up. The wave would come up. The wave peak would come up to touch the bottom of the peak of the wave coming from the surface. That if the power lines have this going in the power lines, and it's going out in an electromagnetic field, goes out maybe 100 feet into the ground maybe, and out into the air, of course, and then Mother Nature's doing this down on the ground. What do you think is going to happen when both waves meet? Interferometry is going to happen. Interferometry is just a complex term to describe interfering things. The study of things that interfere with other things. Now, speaking of that, let's go down to the east by southeast at the middle of our arrow to Richland, Oregon. We have a flow out going through the middle of our arrow. Come on. Same sized earthquakes that are striking up here to the north. 2.0, 1.9. All of a sudden we get a 2.0, 2.1 striking out at the tip of the arrow, heading out over towards the edge of the craton. One more time. But I'd like to look this quake up over at Richland, Oregon, and see if there's anything there. What's the depth on this quake? It's at 6.8 kilometer depth. It's just a small quake, but we need to look these up, guys. We have to look them up. If we don't look them up, we don't know what's there. Sometimes there's something there worth noting. Other times there's nothing there at all. Natural earthquake on a fault. But if I zoom in and I find an oil well there or a power station or something, then, of course, then raise our eyebrows at the location. What's at Richland, Oregon here? Richland, Oregon. Let me turn on all my place marks. And it helps to have all your place marks on already. Okay. There we are. We don't have any marked. Oh, wait. Wow. Sometimes you have to back things out to really see it. Check it out. See this? Looks like a giant crater. It's because it is. Let me turn off the coordinates. There it is. So this thing, all right, this is on the back side of the U shape of blast calderas from Yellowstone. Yellowstone is over here. And then we have a U shape that connects over to this. This, over to the west, not acknowledged by professionals. This, over here to the east, Yellowstone, is acknowledged by professionals. And the past blast arc of blasts that go through the Snake River Plain down here to the south. You can see our other volcanoes that exist through here. Hell's Half Acre, Craters of the Moon. Wait, is that their name? Hold on. That is Craters of the Moon, isn't it? Sorry, guys. Yeah. Hell's Half Acre, Craters of the Moon, and you'll see. It's a line of quakes that goes right through where they say Yellowstone has these past blasts that go over towards Oregon. But they don't acknowledge this big crater up here on the north side, and it is some kind of ancient caldera or crater. It's in the shape of one. It's huge. There it is. It's on the other side of Yellowstone. It looks like a giant smiley face. We're going to turn it on its side, and I'm going to show you something that I've already pointed out to my other viewers. This giant crater is on the backside of what looks like a giant triangular shape. Now, I have to show everybody this. I would like everybody to pay attention right about now. More than anything, I'd like you to look right now to everything that I've showed you except for the turkey stuff at the start of this broadcast. We'll talk about this shape and this crater in a second, but first, I want to show you this one. This right here, this shape, in the shape of a star of a bastion fort. And on the back right side of it is the Grand Canyon itself. This is the Grand Canyon. Huge, right? So this right here is massive. This is 300 miles long. This shape here. And I can search for you. I'm not going to get mystical or conspiracy on you or anything, but I have to show this to you to explain the earthquake up there in Oregon. I'm searching the term star fort. Now, this is going to bring up bastion forts built by the military. But what the shape that I want to show you is this shape. See this? This diamond-like shape? It's in all the bastion forts. This one especially. See the front of this? Right there? I mean, it's all over the world this way. They're finding these all over the place. Some of them are ancient and buried. Others are weathered down and lost. But they all have that shape in common. That specific shape. Again, that diamond-like shape that's coming off the front. You can see it in this drawing even has it right there from, where's that, Wikipedia or something. This is the Fort McHenry Star Fort. But that shape there matters because that shape is this shape. And I will draw it out for you so you can see it because this gets into the quakes that are up in Oregon. So from back here to up here, I'm just going to roughly draw it out for you. And we'll do it in miles just so you can see. It's like 115 miles almost exactly. Then up here, we're at another 300 miles. And then we come over here on the east side, and we're at another exactly 300 miles. And I'm not doing exact, but it is exactly 300 miles. So it's an equilateral triangle. Okay? Now it comes back this way. So we have the star fort shape. One more time. That diamond-like shape. And I'm not pareidyliing this. You know how I know I'm not pareidyliing this? You know how I'm not just seeing shapes? Remember what we just said. It's a military shape, right? The military uses this, right? For shooting cannons. And it's the size of maybe a castle or something. But now we're going to zoom in on the center of this. In the eye of this giant star fort. 300 miles long. And what do we have? Well, I'm not going to make you guess. We have Edwards Air Force Base. Directly in the middle of the eye of this one. Okay, now that's not chance. It's not chance that there's a military base in the middle of this one. Because on the right side is Area 51 and our nuke test sites. Here's the nuke test sites. Here's Area 51. That's on the right side of this thing. On the left side of this thing over here, 29 Palms military base and military bombing range. Bombing range on one side, bombing range on the other, military base in the middle, and in the back middle right here, take a look, Hoover Dam. Back middle exactly, electrical generation. So, it's undeniable this is in the shape of a giant star fort. And it's undeniable that there's a military base in the middle pinnacle tip of it, a bombing range on one side and on the other. Significant, too, bombing ranges. Now we're going to get over here to the one that I just showed you. This one, with the crater on the backside that's not acknowledged by professionals. This one is also 300 miles long, but it's way weathered over time. I'm not paradealing this one either, because you can measure from back here up to the pinnacle tip and back down to here. It starts right back here. You can see the topography does this. These are mountains. It goes up and comes back down to the crater. Now, what's in the pinnacle tip up here? I just showed you the pinnacle tip over here with the military base in it. What's in the pinnacle tip of this one? Let me zoom in and show you. See these? This is the Facebook and Apple data center. Facebook data center, Apple data center. Facebook and Apple data center in the middle of this one. And a big blown out thing on the back side. There's a third one, and it's directly in between the other two. It's the most weathered, and it used to be filled in with water. This one is here as well, and it too is 300 miles long exactly, and I will measure it for you to show it to you. The first one I already showed you here. We're getting earthquakes below the tips of each one of these. I will explain in a moment. And on the back sides. So, earthquakes below the tip of this is the San Andreas. This thing points to the San Andreas. Here's the San Andreas, and the pinnacle tip of the star fort with the military base in the middle points right to it. Earthquakes right below the pinnacle tip and back below the back side of it, back over here by Vegas and the nuke test sites. Over on the right side and over at 29 Palms on the left side. Earthquakes on all sides of each pinnacle tip. Same for the one in the middle. The one in the middle I will measure. Back side of it's right here. It's again 120, 115, 120 miles long. And then it's again 300 miles up to the pinnacle tip. We go right between Lake Tahoe and Pyramid Lake, where we have our giant crater that I found. The one I've been talking about for several years. Lake Tahoe, Pyramid Lake. Right in the middle, big crater, and another giant military base. This one is Hawthorne Military Depot, where they have all the bunkers and they store nukes and everything else there. So in the pinnacle tip of this one, we've got Hawthorne Military Base. In the pinnacle tip of this one, we have Edwards Air Force Base. And in the pinnacle tip of this one, we have the Facebook and Apple Data Center. On the back right side of this one, we have a big crater. On the back right side of this one, we have a giant crash, whatever you want to call it, a smashed point, is the Grand Canyon. And the one in the middle, on the back right side, is the Great Depression, or whatever you want to call it, of Salt Lake City. Salt Lake City, Grand Canyon, giant crater. Earthquakes below the pinnacle tip of here, and up here to the north is Bend, Oregon, where our other big earthquake struck several years ago. And that matters. That's why I had to take all this time to tell you about this one quake. This one quake is in the middle of this giant crater that professionals are deliberately not telling us about because of what the implications are for what these are. Who could build something 300 miles long? Why are they all blown out on the backside? How old are these? And how? It's insane. But there it is. I go where the science leads me, and in this case, earthquakes are striking below the backside, right where the blast craters are, for these giant ancient structures that nobody apparently even knew existed. And the only way I'm finding them is by the earthquakes that are striking below them and zooming out and seeing them literally there. And it's not me seeing them like bases in clouds. There's military bases in the tips of each one. We found a lot more than that. I found at least 30 different examples of that particular shape, dozens, if not hundreds of miles long, with a military base in the middle of each one around the world. Somebody had the ability to build things a long time ago. But why that shape? That shape gets into a combination of a square wave, sawtooth wave, and a sine wave. And if you combine all three, it gives that shape, cymatics, but it only shows up on an oscilloscope. And you have to use a music combination program to even get it to show up on an oscilloscope. But that shape appears when you combine all three waves, sine, sawtooth, and square wave. That shape forms in a replicating fractal that goes on forever. And there's videos of that. If you want to go look them up on YouTube, you can search oscilloscope music. Find the Russian one, and you'll go and see it yourself. You'll see that shape. Why does that matter? In the video, I can't show it because of copyright on YouTube. But in that video, very low frequency electricity is being used through a music program on a computer to combine all three sets of waves to show a shape on an oscilloscope. And it's just going through the tones as it goes up, and that appears. It's not the music program doing it, it's the combination of all three waves. It even gives you the frequency and tone that generates on. So, you guys, there's a connection between these giant facilities, 300 miles long, in the shape of a resonant frequency, and a military base in the pinnacle tip of each one, or something significant. Why would Facebook data center and Apple data center be built in the middle? And why do they have an X marks the spot? You want to see another one? Let me show you another one. Here in St. Louis. Here's St. Louis, Missouri. Here's downtown St. Louis. Here's the old Star Fort that is confirmed an old Star Fort. You don't have to take my word for it. It's on old maps. And the streets still show the outside edge of it, but there's the shape again. And right in the middle of it, what do we have? We have a big X marks the spot housing project. And what's this? The United States Geospatial Mapping Agency that's responsible for mapping all this crap in the whole world with LIDAR and all sorts of ground mapping and maps. Okay, Geospatial Agency is building their new headquarters in the middle of this one here in St. Louis. So what's up with the X marks the spot and the big facility in the middle of one of these that's not even talked about and hidden? I had to find for myself. And why is Facebook data center and Apple data center building their facilities in the middle? Could it be that there's some kind of very low frequency power that's being generated of some kind that they're using for free? I wouldn't blame them if they were. Natural harvestable energy from a giant ancient star fort that was built by God knows who, however long ago, focusing very low frequency somehow from Mother Earth itself. I don't know. The length of this, 300 miles long, says very low frequency or ultra low frequency or extremely low frequency. It depends on how far apart the waves are. I know it sounds real wild and crazy, but that's what's happening, guys. We're getting earthquakes down below these shapes, and these shapes are not being made by Mother Nature. The military is building a base in the middle of each one. You can't tell me that that's chance. And me seeing shapes when there's a freaking military base in the middle of each one, or something very significant. If it's not a military base, it's some kind of other base. Weird, right? The only way I found this is with the earthquake striking next to each one, guys. Let's go down into California. Let's get out of this weird hot mess up here in Oregon. Go right down along the border of Nevada. Is that Nevada and Oregon's border? We have a negative depth earthquake. Now, it's not up in the sky. This is actually up above sea level. So, just want to go see what's right there at the border. Man, we need to move on because that gets just so hairy on me talking about this. But you're coming along with me in this voyage of discovery. You're on the SS Dutch. We are forever doomed to sail the high seas of the internet like the Flying Dutchman. We're glowing green because we're radioactive. What's this place? Denio Junction? Oh, wow. Okay, hold on. Now, down in here, we have open pit mining that's taking place for uranium. Those of you who don't know, east of the Antelope Refuge, I don't know exactly where. This is where the big stink for Uranium One. You guys remember Uranium One? Maybe it wasn't them. Maybe that wasn't the company. Anyway, right out here in northwest Nevada, there is a big uranium thing going on out here. I don't know if it's going to be, it might not be open pit mine. It might not. They wouldn't have it well labeled, that's for sure. Anyway, okay, I don't have any proof on it, so I'm just telling you that spot right there is well known for its uranium deposits. So a small earthquake there would tell me likely that they might be doing some kind of mining, even though it's listed as deeper. Now we're going to go down to the south, and we're going back to that military base that I already mentioned between Lake Tahoe and Pyramid Lake. Remember, those pinnacles of each tip of each one of those giant star forts with military bases in them are getting earthquakes below the tips of them. Let me show you. Again, I would never ask you to believe that. So I'm showing you. Here's the earthquake epicenter. Here's Lake Tahoe and Pyramid Lake. Here's our giant caldera that I had to find myself gets hit with earthquakes all the way around the outside edge of this thing. It's lined with volcanoes. And it is the pinnacle of what I just showed you. Here is Hawthorne Military Base. And just to let you know that they know, when you can build any shape, it's not an ammo range. Take a look. 2 roads. When you can build any shape you want, and you start building shapes like that, and that shape is pointing in the opposite direction of this one that's so weathered and so old, it used to be filled with an ocean. Look, the other two you can see better. The one in the middle, you'd have to know the other two are there to even find it. But now that I know what to look for on the star fort shape, it's a slam dunk that they built the military base and so forth next to and in the center of the pinnacle tip of it. But why? I don't know. The earthquakes are striking all around from Lake Tahoe up to Pyramid Lake. Let me show you what's at North Lake Tahoe. Here's North Lake Tahoe. And right here, Steamboat Springs, volcanic field. So in the middle of this thing, we've got the volcanoes, and then that lets us know that maybe something got overloaded a long time ago. But this would be man-made man-made. Who could have made it? Something that big, 300 miles long, earthquake down below the pinnacle tip of it. Who had that kind of knowledge that long ago? Who had the ability to sculpt mountains, raise mountains out of the earth? I mean, look, the earthquakes are even taking the shape of that tip. Now that I know what to look for, we know to look at each spot. It's doing the same thing at each other spot. Now, down to the south, we're going to go into California's border, and we're going to Mammoth Lakes. This one here is not a star fort, so we can move on from that topic. We're going from a star fort down into a super volcano, down along the California-Nevada border. This one. Now, notice the shape of it. It's just like the other one I showed you. The other two. So this one is Long Valley Caldera. It's well known. It's a super volcano. The other one I showed you up here, professionals are ignoring. And the other one that I showed you up here, the professionals are ignoring. The two that the professionals are ignoring have I think I showed you, have direct ties to giant star fort structures if you know what to look for. So why are they hiding both giant craters tied to both giant star forts they're hiding? I'm going to sip my coffee while you think about that. And that's for real happening. I can't believe it. Down to the south, a line of earthquakes goes through Ridgecrest and then makes a hard bend down to the San Andreas, following the third star fort. Coming down this way. Oh, and by the way, experimental facilities from all the private companies are right here at Ridgecrest, where all the rocket ranges are. Here. For testing all their outdoor rockets. Where they blast stuff away, they'll hook that up, and let's see if I can find one that's got the side blasted out. Here's one. They put the rockets in there and shoot them. Okay. Anyway, the third test facility is on the side of this thing. right here. And it's said that there's a bunch of underground bases that go across the whole Mojave right through here over to 29 Palms on the other side. So now that you know what's there, and you know what shape it's in, what's out at the Pinnacle tip? What's this place? What's all this? That's Frazier Park. That's where the San Andreas comes down and goes all the way down to 29 Palms. But this giant thing is pointing to where all the earthquakes are striking. And that's no exaggeration. There's earthquakes going right along it. These 3 quakes, quote unquote, in the middle of the Mojave are quarry blasts, where we're doing all sorts of digging on top of the military base in the middle. I wonder why they have all the quarries out there in the Mojave. Couldn't they get the stone from anywhere? Oh, they've got really good sand out there, Dutch. No, they're getting boron out of the ground. Let's go down into the L.A. Basin, shall we? Or should we go along the coast and down into the valley? Let's do that. Let's go along the coast. Start back up here in Northern California, where I have a warning for a 5.0 range earthquake to strike. Listen up. Everybody's been dumbfounded and blinded by the damn star forts. Listen here, you damn Zoomer kid. Take your ear pods out of your ear. Get the hell off your hoverboard. Get off my front lawn. Listen up, guys. No, I'm not drinking a Monster Energy. I'm drinking coffee. I'm Boomerville times 20. Now, check it out, guys. Up here on the north side, we're watching for a 5. Did I get your attention? 5.0 we're watching in Northern California on land next several days. There's a line of earthquakes going from the south tip of the lightning bolt-shaped Juan de Fuca fracture zone. Let's go back over to that USGS plate boundary map, the one that I showed you at the start of this broadcast, and go look at California. So you see the lightning bolt shape of the Juan de Fuca fracture zone. Those jagged edges belong to the Pacific, like sawtooth edge. It gets locked there. The wave comes in, goes into here, and then goes down through California and over across the Craton. So when the Craton gets pushed from the west, it moves to the east. Turn the Craton graphic off. And we're coming in from the northwest, looking for a new 5, right where the Juan de Fuca comes in on land. That's Eureka. That's Northern California. The rest of the earthquakes go from there, and there's a huge stack. The untrained eye should be able to see giant stack of earthquakes at the geysers, which, don't worry, it's a volcano, but it's not going to erupt. Humans have drilled the hell out of this place to get steam. They inject sewage down into the ground. They put the nasties down in the ground, steam off the water to come up and turn your turbines. Turbines, not, well, I cracked the joke before, but I'm going to do it again because it's freaking funny. Turbines. You have turbines out there. You're putting your sewage, human sewage from your house, down in the ground. That's fracking if I ever... That's a hell of a way to do fracking, isn't it, guys? And a toxic... Oil companies like, oh yeah, you guys go, you go. So here we are. We're at a volcano where they're injecting water. No wonder there's a bunch of earthquakes there. But going from there, we go in a diagonal line down through the creeping section of the San Andreas. Same-sized earthquakes all the way along the way. 2s, 2.3, 2.4, 2.5. All the way down through the creeping section. But then we jump over into the valley. We jump off the San Andreas. Do you see the diagonal line of the San Andreas? Going over into the valley. Cantua Creek, California. Guess what's over in the valley? It's not a volcano, and it's not a star fort. It's pretty much the only other thing I've been showing you in this broadcast. It's farms. No. It's all of these. Now, you might not know what to look for, so let me just show you. Starting right here, going all the way down and around the bend. These are drill points. Tens of thousands of them for oil and gas. And let me prove that to you. A shadow of a jack of a pump there, or 2 pumps actually. And that's just one pad. And you see how many pads there are. They go up here to the north, and spread out to onesie twosies into the foothills. And then down to the south, this is where we go into overdrive. Now, wait a second. San Andreas. It's right here. This is the San Andreas. And we have earthquake. That wave is coming down the San Andreas. The wave I showed you at the start of the broadcast. The very low frequency wave. It's going in and coming down. And then it gets to here. And we've stepped in and done all this drilling right along the San Andreas. We've drilled from here, following the San Andreas, all the way down. This is all drilled. All of this. Every bit of it. Do you see it? Here, hold on. Do you see how many there are? It's not a well storage yard. Open your frickin' eyes. Take a look. Seriously. Somebody in the past already knew a wave was traveling through and would spread and transfer and all that crap. Because all this crap, all the stuff I found that they've denied, somebody had to know. That's had to be why they put it all here. Look, it goes right up to it. And why would they stop? Right? Like, if they said there's no effect, why wouldn't they just carry on right across the San Andreas then? Why drill right up to it to create a perforation? And all of this is drilled. So, I mean, we're talking just millions of drill points. Go back up to the north. This place is called, of all things, this place is called Missouri Triangle. We turn on the borders and labels. You'll be able to see this in about 2 seconds. Yeah, Missouri Triangle for some reason. Right in here. Oh, is it going to come up? Blackwell's Corner. Huh. That's interesting. Well, the name of the place is... Oh, there it is. Missouri Triangle. Where all the drill points number in just insane. Let's get a ground level view of this masterpiece that humanity has created. Let's go to the crossroads out here like Tom Hanks at the end of Castaway. Go look out in all directions and see which way we want to go to have a better life. It's kind of looking like Mordor on a nice day. Partly chemtrail day. Look at that. Oh, now there's no such thing as chemtrails. Man-made clouds. Let's call it man-made clouds. You know what a man-made cloud is, don't you, kids? Dirty jet fuel that's intentionally dirty, doped even. Doping is when you lace something with something. And aircraft filled with people that are paying good money fly across areas and leave what are called contrails. But these are not like regular contrails. They linger for hours, if not even days in some cases. And they combine with others and they form into what are called man-made clouds. Not to be confused with some kind of plane flying over with nozzles on the back, which the U.S. military already did back in the 1970s and proved that it works. But with this, it's much more innocuous. You can get away with it easier, and it's just cheap jet fuel. Now, you could call that chemtrails. You could call that chemicals, which I guess it is. But it's just man-made clouds from dirty jet fuel. And NASA is aware, as well as the U.S. government and National Weather Service, that this happens, and they use it. They'll direct air traffic in certain areas where they want to engage in what they call solar radiation management. And the FAA is on board with this. They started doing it a few years ago. And, well, they say a few years ago. We know they've been doing it for many years. And they'll do it, and they'll target planes to fly over areas in a grid and in a spider web type shape. In areas where they know there's going to be a high solar load, and they want to create a block. And they do that called solar radiation management, SRM, using cloud seeding from unintentional clouds created from contrails from dirty jet fuel. Anyway, that's your little science lesson on cloud condensation nuclei and how it can be generated from particulate matter that's heated up into a jet engine and shot out the back mixed with moisture. Not to be confused with nozzles on the backs of planes. Because we know they would never do that. But, you know, which is better, right? I'd rather have the nozzles with planes. At least you know there's like a single substance. The dirty jet fuel, they'll probably lace it with all kinds of stuff to get the more bang for your buck and to create the clouds. What do you want to bet they get some kind of environmental tax write-off for doing solar radiation management? There's such a thing called the Climate Stock Exchange, don't you? Up in Chicago, the CSX, started by Al Gore. They're the ones that sell the carbon credits to all the big companies. The companies pay this Climate Stock Exchange, and then they get what's called a carbon credit for the pollution that they create. And the Climate Stock Exchange farms out all kinds of crap to people to do around the world to save the environment, and they offset their pollution by planting trees in Tibet, supposedly. That kind of shit. Pardon my language, but so the Climate Stock Exchange, you get your carbon credits. If you're a company, you buy your credits for what you do that's wrong. Well, what do you want to bet? Those who create the solar radiation management clouds get some kind of carbon credit. Just a bet. I don't know. That's my conspiratorial mind thinking. So let's go ahead and wrap this up, shall we? This has gone on long enough. You can certainly tell I needed to talk for a little bit. But we're going to watch Northern California. We're going to watch over in the West Pacific. We're watching with the deep earthquakes. We're watching down in New Zealand. This is not really a forecast. This is just a long-winded update. It's 4:15 in the morning now. My time. Wow. If anything else goes down, I'll jump back on at a moment's notice. That's a recap of pretty much all the earthquakes. If you're in Turkey, I missed. It happens. I do miss. If a 7.0 earthquake strikes tomorrow or something, then that's the earthquake we're looking for. But I don't extend these warnings. I don't get back on and be like, oh, we just need to give it more time or something. No, I take it as a full humiliating defeat, and I need to figure out where the energy went. Where did that standing wave go? And we know it went back to Tajikistan, got a 6.8 to 7.0 earthquake in Tajikistan, reflecting back into itself. But where is it now? It's in between Turkey and Tajikistan, which is Iran, but no break in Iran yet. Anyway. All right, do you have an earthquake plan? I end every broadcast saying this, and I just hope people take the time to do this. You need to know what to do when an earthquake strikes, whether you're in Turkey or whether you're in the United States or anywhere else. Your buildings are going to be different, but we can all pretty much respond the same way. Get underneath something to protect yourself from falling debris. If you are not confident in your structure, you need to know where to go outside, and that's tricky. You're going to be running outside into things that could be falling from much higher than inside. They'll be moving faster and they could be bigger. Now, you can make those decisions, but if you're going to be outside or if you're going to be inside after an earthquake, you should probably have an emergency kit. And that'll have a change of clothes, set of shoes, flashlight, batteries. You don't want to have to use your phone for a flashlight. You might not have power for a while if it's a big earthquake, so think about that. Also, medicines, first aid, you need to have those things covered. Sanitation as well, and that food and water. Cannot stress that enough. Food and water, you're going to need high energy, high sugar, high protein, prepackaged, lightweight for the food. And on the water, it's heavy. What is it, 7 point something pounds a gallon or 8 pounds a gallon? Whatever it is, it's heavy, and you probably would want to have a pump or a straw or some kind of those purification, some way to purify water so that you can drink it. Okay, I'm just giving you the basic ideas. You will come up with way, way better ideas. I hope you enjoyed this update. I'd like for you to chew on that info on the star forts and the earthquakes down below the pinnacle tips of them, and the size of them, and who could have built something like that, and why is there a military base in the middle of each one, and a Facebook data center. Facebook and Apple. You couldn't get any more suspicious. It's so bizarre. You can't tell me all three of those are chance, and I've got more than 24 other examples that I found. It's actually way more than that. It's actually like 50 or 60 different examples, but we certainly have about 25 to 30 different locations, maybe even more, that have a military base in the pinnacle tip of one of these, but they're hundreds of miles long, ruling out
bastion forts and cannons, unless the cannons are the size of New York City. And the people who were operating the cannons would have had to either been operating Death Star type cannons, which we don't have anymore, or they would have had to have been huge and took their cannons away, and all they left were the big bases for them. It doesn't make sense to have a military base in the middle of each one. It's insane. Okay, enough of that. Be safe. I'm saving this as a video. It is now 4:20 a.m. Central Time, right on the dot. Have a good morning, afternoon, evening, or night. Peace out.